This question is coming from October number 20, paper 3, variant 2, and this is the seventh question of the paper. We are given a differential equation, and it's given that t has to be greater than equal to 0, and we have to use this information that x equal to 0, t is equal to 0 to find the integration constant. And the first part is asking you to solve this differential equation and get it into this format. So as usual, the first step would be to separate the variable such that the derivative's denominator goes to the other side. So it means that the t term is going to be on the right hand side and x term will be on the left hand side. So it's going to become 1 over cos square 2x dx is equal to e to the power of minus 3t, because of course 1 over e to the power of 3t is same as writing e to the power of minus 3t. Or let me just write for now e to the power of 3t in the denominator, and of course dt is also gone to the right side. Now we have to integrate on both the sides. How do you integrate 1 by cos square 2x? We have no formula directly if you look into your integration formulas or your integration roadmap. But what I can do over here is I can use the trigonometric manipulations and convert this into the sec square 2x format. So this is my sec square 2x dx. Now, along with this on the right hand side, I can convert this into the format that I was talking about, e to the power of minus 3t dt. Because I know how to integrate this, I don't know how to integrate this format. So how can I integrate sec square to x? Of course, the sec square x integration is 10x. So I can convert this into the 10x format. So it will become 10 of 2x. And then of course the reverse chain rule will make the derivative of this term go in the denominator. And on the right hand side, e to the power of minus 3t will become e to the power of minus 3t. Then with the help of reverse chain rule, the derivative of this will go in the denominator, which is minus 3. And now I can have the integration constant on the right hand side. Now I can go ahead and find the value of c by substituting the values of x equal to 0 and t is equal to 0. So I'm just going to write a statement that substituting x is equal to 0, t is equal to 0 to find, of course, the value of c. And if I put the value of x equal to 0, 10 of 0 will be 0. So this is 0. And over here, anything to the power of 0 is 1. So c will become equal to 1 by 2. So I can just say that c will be equal to e to the power of 0 by 3, that is equals to 1 by 2. And from here I can say that the solution of differential equation is going to become 10 of 2x, or let me write it in a proper way, half 10 2x is equals to minus 1 over 3 e to the power of minus 3t, and then plus c. In place of plus c will be writing plus 1 over 3. Now we have to bring our answer in this specific format. Basically we have to make x the subject of formula. That is our main focus. So for that, what I can do is I can first of all shift this 2 on the right hand side, so that you can get 2 by 3 as a common. You can see 1 by 3 is a common, and then if you multiply 2, of course this term will become minus 2 by 3 and this term will become 2 by 3. So I can take 2 by 3 as a common, and then I can write this constant first and then the e power of minus 3t term. So yeah, I think we have almost got the answer. So 10 of 2x is equal to, I'll take 2 by 3 as common and then write this one and then this minus e to the power of minus 3t over here. I can see, yes, we have got that particular format over here. Now I just need to do 10 inverse and then divide both the sides with 2 to get x the subject of formula. So therefore you can get x is equals to, first of all, 10 inverse and then divide both the sides with 2. So it will become half of 10 inverse of 2 over 3, 1 minus e to the power of minus 3t. And that is how we are done with this question. This is the first part of the question. Now for the second part, it is given what happens to x, what happens to the value of x when t tends to infinity. So in this entire equation, t is coming only in one term. So e to the power of minus 3t, what happens when t becomes infinite? So in this case, if you are not really aware about the graph of e to the power of minus 3t, which basically is an exponential decay curve like this, we know that as the value of t will increase, the output of this exponential decay will simply approach to the value of 0. But let's say if you're not really aware about this, what you can do is you can use your calci and write e to the power of minus 3 and then keep on writing higher values and see what happens to the term e to the power of minus 3 of that value. Let's say if I start with 10, I get 10 to the power of minus 14. What if I get 100? You can see that the value is approaching to 0. It is not exactly 0. It's just that my calc is not able to support that many decimal places. So that is why it is showing you 0. It's just like you're having a lot of zeros over there. But yeah, this value is going to approach to 0 as t tends to infinity. So how do you write the answers over here? Let me just go ahead and write a statement that for my second part, for my B part, as t tends to infinity, I can say that e to the power of minus 3t terms tends to, 0, not infinity. And if this becomes 0, you are left with half tan inverse of 2 by 3. So this will imply that x approaches the value of half tan inverse of 2 by 3. This will become your final answer over here. Your x is not exactly equal to half tan inverse of 2 by 3 because this will never reach to 0. It will reach approximately equal to 0. So yes, this is our final answer that x approaches the value of half tan inverse of 2 by 3.